Question number 19. ME 2000 one mark question. Disposable pattern are made of disposable pattern are made of A. Wood, B. Rubber, C. Metal, D. Polystyrene. So in this disposable pattern or expandable pattern, both are same. So that means the pattern for each and every operation, casting operation, the pattern has to be removed. Instead of removing from the, by breaking the mold, you heat the mold and it will come out of as liquid or gas. In these following options, whichever polystyrene is one of the plastic pattern where you heat the mold such that to temperature the plastic whatever pattern will come out as a gas. So answer is D. Question number 8. GATE 2006. An expandable pattern is used in an expandable pattern is used in A. Slush casting, B. Squeeze casting, C. Centrifugal casting, D. Investment casting. So expandable pattern, we know that wax pattern is used in investment casting. Wax is a expandable pattern because once mold is prepared, we remove the pattern by heating the mold, thus that the wax pattern will become into liquid. We will remove the liquid by tilting the total mold. So that's why it is called expandable pattern. Answer is D. So this is all one of the important bit where you will get question. Next question number 17. One mark question, 2001. Shrinkage allowance on pattern is provided to compensate for shrinkage. Shrinkage allowance on a pattern is provided. Shrinkage allowance on pattern is provided to compensate for shrinkage when I will read options instead of writing, because every option is to use. So first option A is the temperature of liquid metal drops from pouring to freezing temperature. This is not the right option, because the shrinkage occurs in three stages, as we have discussed. First stage is liquid stage, liquid shrinkage, and second stage is conversion, latent heat transfer takes place, right, while the converting from liquid to solid. At that stage shrinkage happens. Next stage is solid shrinkage. These three stages will be there. Liquid shrinkage, liquid to solid shrinkage. First two stages shrinkage. These two are first two shrinkage stages in the solidification, especially in cooling. So these two are compensated by providing riser in the casting. So this riser will supply, acts as reservoir and supply molten metal whenever the contraction starts. So once the entire casting will become solidify, then after that it won't supply molten metal. So for that shrinkage alliance is provided. So option A is wrong. Option B, metal changes from liquid to solid state at freezing temperature. This is phase transition, latent heat transition, or latent heat takes place, or change of state takes place. This is not the right. This is stage 2. Stage 2 is compensated by providing riser. C, the temperature of a solid phase drops from freezing to room temperature. So this is right. So shrinkage allowance is provided when the temperature of the solid phase drops from freezing to room temperature. Option D, the temperature of metal drops from pouring to room temperature. It is, that's also wrong. So answer is C. Next, question number 4. GATE 2008. While cooling, a cubical casting of side 40 mm undergoes. So a cubical casting is given. Undergoes 3%, 4%, 5% volume shrinkage during liquid shrinkage, phase transition to solid state respectively. The volume of metal compensated from the riser is. So here again the same concept. If you know the concept, then you can solve this problem in just fraction of seconds. Given a cube of side 40 mm, shrinkage, 3 stages shrinkage, right? Stage 1, which is solid shrinkage. In this, freezing temperature to pouring temperature to freezing temperature. So pouring temperature to freezing temperature, 3%. This is volume shrinkage. 3% of the volume shrinkage happens. Stage 2, shrinkage, phase transition shrinkage. This is 4%. Stage 3, first one is liquid shrinkage. Please correct it. So first one is liquid shrinkage, where the molten metal from pouring temperature to freezing temperature. This is liquid shrinkage. Next one is solid shrinkage, freezing temperature to room temperature. It is 5%. So this is a percentage volume shrinkage happened at each stages. So volume of the metal compensated from the riser is, the question he has asked is volume compensated by riser. So option A, 2%, option B 7%, option C 8%, option D 9%. So to solve this question, this one is 8%. You should know about the shrinkage concept, metal shrinkage concept in casting. So here he is asking the volume of the metal compensated by riser. So riser compensates metal which is compensated at stage 1 and stage 2. To compensate liquid shrinkage and phase transition shrinkage. So if you look at the options, the volume shrinkage in liquid is 3% and volume shrinkage, phase transition shrinkage is 4% in the problem he has given. So riser compensates 3% of the volume and 4% of the volume. Out of A option is not the right, so A is wrong. And look at the C, 8% is wrong, because 4 plus 3 is 7%. Answer is B. So that's about questions they have asked regarding shrinkage so many times. So this is one of the important concept. So next alliance is, we have discussed 3 alliances. One is shrinkage alliance, another one is machining alliance, another one is draft alliance. As we have discussed that if a draft alliance is not required for expendable patterns like wax and mercury and polystyrene, because we won't remove the pattern, so with hand we remove it by heating in different forms. So next alliance is shake alliance. Fourth one is shake alliance. So removing pattern from the mold, while removing the pattern, what happens is, suppose for example, I will just draw a simple diagram. So this is a mold and the pattern is there, like this is pattern, and this one is 2 boxes, one is cope box, another one is drag box, sand. Cope box, drag box. This one is pattern. So this pattern is removed. While removing, what happens is we have to shake the pattern for removing the pattern from the mold. So while shaking, suppose the actual size of the pattern is 50 and 50 mm, it creates the same size of the hole or cavity in the mold. So what happens is, we are before removing, we shake the pattern such that the size will, the whole cavity will become bigger than the required. So that's why if you want to have a casting of 50 mm, you need to reduce the size of the pattern like 49 such that after shaking it will anyway enlarge the hole. Okay, so that's why this is called negative alliance. Why we have to shake is, we have to shake the pattern to avoid the damage of molding sand falling into the cavity. It is also called as due to adhesive property of the pattern, adhesive property of the molding sand. Adhesive property means attracting different molecules. Like cohesive property of sand means attractive force between each sand particle. Adhesive property of sand particle means attractive force between sand particle and pattern material, because both are different materials. If there is attraction force between different materials, that is called adhesive property. Due to adhesive property, while removing the pattern from the sand mold, the sand tries to stick to the pattern. So part of the sand will stick, some part of the sand to the pattern, and some part will fall into the cavity. So to avoid this, we shake the pattern before removing it from the mold. So that's why cavity size will become bigger. Okay, shake alliance to avoid damage of, shake alliance is provided, it is provided to avoid damage of sand falling into cavity. Due to adhesive property of sand. It increases the size of the cavity. So that's why we need to reduce the pattern size to get the required size. Suppose I need a casting of 50 mm, I want to create size of pattern less than that, because we are anyway shaking it, which produces the same cavity 50 mm. So it is also called negative alliance. Negative alliance, because we are decreasing the pattern. Generally in all alliances, suppose if you take machining alliance in pattern, we will add for machining alliance, because that will help. Suppose after removing the casting from the mold, we need to remove the material from the casting. So that's why, to compensate that, we are adding material to the pattern. Similarly here in shake alliance, we need to remove the material from the pattern such that after shaking it will compensate. That's why it's called negative alliance. So this alliance shake alliance is not provided for expendable patterns or disposable patterns. Expendable patterns like wax, mercury and polystyrene do not require shake alliance. Next alliance, distortion alliance. In the case of thin and long shaped components like U-shape and V-shape channels, C-sections, there is a possibility of bending due to shrinkage forces acting outward direction, such that we get required U-shaped component. So this is happens only thin shaped components. It is provided only in thin shaped components like U shape, V shape, C sections, to compensate shrinkage due to bending forces.